talking about today is something called net ionic equations. And when we looked at the equations with double replacement, we said if everything was aqueous, it didn't run. And we talked about why that was the case, how if everything was floating around in here, you're not going to have anything meeting up and changing to form a solid, a liquid, or a gas in the process. So what we do with these double replacement reactions is we look and see what is produced and just have those components in our reaction, okay? So the things that are just watching the action going on, those things are called spectator ions, just like at a game or something. The people who are watching are called spectators. In our reactions, where we actually look and see what is reacting, those are what we find in our net ionic equations, okay? So when we do these, we have our balanced equation that we start with. Then we break everything out into ions, and then we cross out the spectators and rewrite it with just what actually took place in the reaction. So what should be over here in your products for this year? Now, when you get into AP, things change a little bit. But for this year, the only things that should be on this side, on your product side, are a solid, water, or a gas. And let me show you how to do some of these, okay? So we're going to take some of these as examples. And then, so I'm going to show you the long way to start with, and then I'm going to show you a shortcut method with these as we move on, okay? So the first one is sodium hydroxide. So you write the formula for sodium hydroxide. Write the formula for copper 2 chloride. Then we go through and we swap we write our cations in the same spot, put our cations there, and then we swap our anions. So the OH here is going to go with the Cu, and the Cl is going to come over here, okay? You need to look and see what's going to be participating in the reaction. I don't need to look this one up because I've got an ocean full of proof that this is aqueous, right? Salt water, you guys know that one. So if you know some of these, you know, okay? So we don't really need to check our chart. This one we don't know. So we're going to go back. We're going to check our chart from here. So we're going to look for copper 2 hydroxide on our solubility chart. So here is copper 2. And I'm going to look for the hydroxide. And when I see the hydroxide, it has an N here, which means I'm going to go back here and I'm going to write in my solid here. Okay? That means that the reaction is going to run. So since I know my reaction runs, I'm going to go back and balance my equation now. Over here, I've got 2 OHs. So I need to put this here to get the 2 OHs to balance. Over here, I have 2 sodiums and 2 chlorines. So if I put a 2 here, now I have my equation balance. So nothing new up to this point. This is just a standard double replacement reaction. Now, this is where things get different. Now we are going to go through and we're going to break these out into ions. Okay, so I'm going to have 2 Na plus ions. I'm going to have 2 OH minus ions. I'm going to have 1 Cu2 plus ion. And I'm going to have 2 chlorine ions. Now, this is where a lot of people mess up. Chlorine is a Brinkelhoff. And you say to me, Lippy, this is a Brinkelhoff. This is a diatomic ion. You're supposed to have a 2 down here. Not when we're in an ion form. When we're in an ion form, that chlorine ion actually breaks up in that water and it's floating around. It's not bound together in a compound, okay, when it's in this ion form. So no, do not have that as a Brinkelhoff. You're not going to have subscripts in this line of code, so to speak, okay? Unless it's part of a product. But on this side, you're never going to have subscripts. Okay, so I come over here. Anything that's aqueous, I'm going to break out. This is not aqueous, so it stays in its form. All right. Now, the next step is I am going to look and I'm going to see what is the same on this side and this side. So this is the same as this. So I mark that off. This is the same as this, so it gets marked off. Then I rewrite this with what's left. And that is my net ionic, because in reality, that's the only thing that's changed. Good? Okay. So if I go here and look at another one, we've got barium nitrate. I've got sodium carbonate. And barium. Oops, shoot, sorry. I try to model the same stuff for you guys. It's not doing that for a minute. All right, so the first step is, before I even bother to balance this, I balance my charges and I balance my formulas right away. But before I bother to go any further, I'm going to go and see if the reaction's even going to run. So barium carbonate, barium's here, carbonate's here, that has an N. That means that reaction runs because this is going to form a solid. Then we go back, we check our sodium and our nitrate. Nitrate is here. And sodium is here. That is going to be aqueous. So I put down an AQ here. Now, I told you I would show you a shortcut. I need to first balance this. So I'm going to put a 2 here and get it balanced. So what I do, and you don't have to do the shortcut. It's up to you, but I want to show it to you, show you as an option. What I do is I look to see what makes the reaction run. I formed a solid here. So I go BaCO3 and I write the solid out. Okay. Then I go over here and I identify what made up this. So I have over here, I have a barium 2+, and I also have a carbonate 2-. And that's my net ionic. And I didn't have to write all that extra stuff out. Okay? So if you get into college and your professors make you do this, they may require to see this step. But if you're taking the AP exam, we're always looking for shortcuts and time savers. And if you can identify that this is your solid from here, and then just go back and pick up the components of that, you've just saved yourself a lot of time. That makes sense? Make sure when you get down to this portion, though, that this is balanced, because it's a good double check to make sure that everything's done properly up here. Okay? You see, we've got potassium iodide, so Ki, and we've got silver nitrate, AgNO3, potassium nitrate, That's aqueous. You guys know how to look those up. And silver iodide is the next one. I need to check that one. I don't know that one off the top of my head. Some of these I've got, other ones I don't. So silver iodide, okay, that is a solid then. So it's going to form a solid. So see if you can get the net ionic for this. Okay, good. Easy enough. Aluminum chloride and sodium hydroxide. Okay, that does form a solid. Okay. Yeah, some of these I have memorized, other ones I don't. So, put a 3 there, and come back over here and put a 3. Okay. Okay, good. Questions? Okay, last one. This is the last slide of the whole shebang. We got lithium sulfate and calcium nitrate. Going to form lithium nitrate and calcium sulfate. That I got to look up. Calcium sulfate. Okay, it is solid. So I do need to balance my equation. Oops, didn't have that written correctly. There we go. So SO4, calcium, and there you go. All right, questions about any of these? Okay, so then you've got your next homework packet, I think is 9-8. Is that correct? Yeah. So that's out. I will get the answer key for you to kind of reference here in class. You can work on these and see how you do. Okay.